All right, Wednesday night coding time. Uh, this stream is for entertainment purposes only. Let's try to not solve another problem under 40 minutes. So with that, let me quickly check if everything is up and running. And we can start. Yep, seems like that. So let's see what's the problem we'll get today. It's a hard problem, so all right. So let's just see. Whatever 40 minutes passes, wherever we stop, we stop. I have no intention to solve hard problems today. Let fx be the number of zeros at the end of x factorial. Recall that x factorial is factorial, and by convention, 0 factorial is 1. For example, if 3 equals 0 because 3 factorial equals 6. There's no zeros at the end. Well, f11 is 2 because 11 has 2 zeros at the end. Given k, find how many non-negative integers have the property that fx equal k. Well, hell no idea. In the range from 0 to 10 to the power of 9. So when we gonna stop in terms of x? Unless you try every single x as you go, and then start with some arbitrarily large, it will calculate factorial, and then you track number of zeros at the end. But this definitely cannot be solved that easy. Number of zeros. So basically, I don't see any obvious. Okay, so we don't have even hints here. So let's see what's the at least related topics. Maybe this will give us something. Binary search. And how on earth binary search can help here? Yeah, we know that the resulted array of factorial x, right, it will be sorted starting from 0, which is 1, then 2, 6, and we go further. So it's sorted. This helps. Given k, find how many non-negative integers but I'm not quite sure if there is a way Ah, I think I got it. You don't technically need to compute factorial. You need, all right, let's consider how we multiply things first, right? Let's switch to the whiteboard. So I don't understand how this can be when research and why it's related, but let's see, maybe we will see something. So far, I don't see anything. I don't know even how to start solving it unless so the only way I see it, like you run factorial calculation, which is, as we know, with recursive algorithm and memorization technique can be done quickly enough. And because you memorize on the way you go, so you select arbitrarily a large X, which will take probably a lot to compute, maybe not enough even in memory. And then you store on the last K digits, right? So because we don't care about other stuff, we only store first 5K digits. So, and every time all of them gets to 0, we add 1 to the result. The problem is that so should we try, but then what's the largest X we can see? So let me see, let's say K, let's say 2 zeros, right? So we already know that this is 11, but maybe there is a pattern or something. I don't understand why the number of X should be finite. Can it be like infinite because it repeats itself? Maybe there is some period or something. So maybe not. So let's see, 1, 2, 3, 4, 5, 6, 7, right, 8. So we start with this, we get 2, then this, we get 6, then this 24, 120, and we interesting, so we don't care already about 1, right? So we keep this one, then this, it's 0, 2, something there. Then this is what is 0, 4, something there. Then this is 0, times 4, 32. So let's see. Factorial of 8 should end with 20, right? With 20, right? So, All right, so 9, 0, 10 is 0. Mm. 10 is 2 zeros, 11 is 2 zeros, 12 is 2 zeros, 13 is 2 zeros, 14 is 2 zeros, 15 is 2 zeros. 15 is 3 zeros now. I see. So the number of zeros keeps growing. Is that the case? Because once it's 0, right? It never becomes back the to non-zero. That's why. Probably still interesting like binary search though. And why there is no such x that ends with k equal 5 zeros? I don't understand. Yeah, I don't know. Well, int k mask equals what 1 k, right? And then int cnt equals 0. So the dumb version of this algorithm, let me switch back. So the dumb version of this algorithm would be just go in cycle. Okay, k plus 1 actually. So even one more. So once we hit next 0, so there will be never case when there is less 0 than that one, right? So all we do, send this int num equals 1, right? And while num percent k mask not equal to no. K mask is what we filter out, right? But then we need to count a number of zeros which is so if k0 return equals 0, return 5. It's obvious. I mean, corner case that is already computed. Whatever, we won't do this, so we want to. Okay, so the idea is not equal 0, right? And we can also say int x equals So because we already have this corner case k equal 1, k equal 0 return 5, so we may start with x equal 1, because if there are two zeros, we don't need to compute it. Now the question is, if num percent k mask not equal 0, and so we should say that and so k mask is 10 plus 1, so right, so it's, let's say, 3 zeros. So until x is less than this number, we should not stop. Is it x or the factorial itself? I guess the num, right? And the num, while not equal 0, and num is less than k mask. I think this one, right? So what all we do this. We say num, which is 1, which is initial 0, times equal x, and then num percent equal k mask, right? Because we don't care about what's after the k, and then we say x plus plus. Will this gonna work? All right, let's see. So we start with, so num1, start with factorial, start with 0 equals 1, right? So the special case when k is 0, we don't consider it because we already have it. Ah, I see. So this should be k mask divided by 10 because we added plus 1 here, right? K mask divided by 10. If two zeros, then mask is 1000. So once we hit 3 zeros, right, at the end, we stop. And once, So let's say we need two zeros, right? So once we get the third zero, that's it. We can stop. So we don't need anything here. But if, let's say we have, if it's two zeros, then the num will be, let's say, 100, 200, 300, 400. It will return still 200, 300, 100, right? Unless it's just zero, but it never starts with zero. We exclude this, so we don't need anything here. So we start like this. We say num times x, right? So it's 1, and maybe even simplify it like plus plus. Then, yes, we say k mask itself. So we count one extra digits. That's what we are looking for. All right. And all we need to say that if num percent k mask divided by 10, right? Or we can say 10 times of num by k mask equals 0, all right? So if it's 200, then we check if 2000 divided by 1000 is 0, then we increment plus plus. Let's see if this thing is going to work. I doubt, but let's see. I don't understand why binary search here, really. It should be k large one, right? Let's also check cout. K equal to k, all right? And k mask equal to k mask. So it's while, we should return, obviously, CNT. Just one-time use to check if its k mask is 10. K mask is 2. Ah, no, 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 no. It's not this. It should be power, right? It should be power of 10 to we don't need to shift it. K mask 10. Okay, nice. So we can return this back here. So what happens if I start like this, right? So most likely CNT will be wrong because we start with the wrong one. But technically K mask by 10 times num, so whatever number it is, let's say 220 by k mask equals 0, CNT plus plus, right? It should work like this. Let's see. Or maybe offset by 1. No, it works like this even. Interesting. So we don't need special case. So let's submit and see what fails. Output 1, expected 0. Ooh. So K mask is 1 million. All right. Let's check every time. See out. X equal X, right? And fx equal num. Let's see. Run code. Oh. Yeah, it adds extra 1. That's the problem. So this check should go first. This way it will work as it should, I believe. Run the code. x1, factorial 1, x2. This is also 1, which is weird because for 2, it should be 2, right? Let's do it like this. And then do x plus plus here later. So run code. Let's see if it's synchronized. And let's, to be precise, let's also say percent k mask or whatever. So it doesn't look confusing that Factorial is computed wrongly. Right. And then we can stop. Okay, so the only thing is missing is x is factorial 0, right? So let's see in the description. You see 5 factorial doesn't count. So what's the factorial of 5? Yeah, it's 0. Exactly, so it ends with 20. All right. So something is missing here. Because it should start with 0, technically. Right, so when it's 1 is 1, when it's 2 is 2, 3 is 6, 4 is 24, and this is 120, so it ends with 0. We shouldn't count it. We shouldn't count it, and yet we do. Then let's do while. But then we should start with 0, all right? x equals 0 question, and then 1, otherwise x. So this is the only corner case we have. Let's see. So I mean, I can break within the cycle before counting, right? So we just don't care. Okay, let's return while back. So all I can say that and num_k mask not equal 0, right? So that's the one, not equal 0. So then it will be perfect again. All right. So we comment this, and let's submit and see if it passes. So should it be long? How much is that, by the way, already? Oh, it's third test, all right. So num percent equal k mask, obviously. Run the code. Submit. Okay. Long. Okay, long doesn't work in this case even. Ooh. Well, how do I check then that specifically? Maybe I can use for cycle. And just iterate through the string. But this is stupid. So how much time do I have? Okay, it's almost 40 minutes. So all right, so we found the working algorithm. The problem is we can fit it into the memory. Let's see if we can trick the system. We shouldn't do this, but let's imagine if k is greater than whatever 70, return, I don't know, 0. Let's see how this works. We'll say wrong error most likely. 36 is outside, whatever, let's just say 30. It's just weird how you're gonna count this if not multiply, right? Maybe that's why you need binary search. Submit. Okay, so let's see how much we can fit there. 20, 30, no 20. Submit. So we were on the, oh, it's 8 test. So if k equals 25, return 5. But no, obviously it's not going to work. But other than that, return 0. More than 25, return 0. Submit. And then it will fail. Yes. Okay, if it's greater or equal to 25, return 0. So don't care about this one. Submit. All right, so how far we've got with this. So for low k, it's working, right? 9 out of 44. Okay, let's stop here for today. We're fine. And so we still have like 5 minutes, but I mean, unless I just don't understand how we're going to multiply numbers. So how do we? So it seems like there should be different algorithm that uses binary search. We can do it like this simple way. So let's see. A plus plus mf long max while 0 0. So he has function zeros. All right, how many zeros while mf answer 0. All right, whatever. Doesn't look like a binary search anyway, so I'm not sure why. But okay, so there might be some tricks how to bypass this k-max and k-mask, and instead of using this modular of this thing, using something different. But if k is not that like super crazy large, like 25 or whatever, it should work in the rest of the situations. All right. So we haven't solved it again, but we solved it 9 out of 44, still something. For the hard problem, it's okay. The algorithm itself was done, but only for small k, not for large one. So at least something. Let's switch to the whiteboard. And so let me see, it's 8 out of what? 9 out of 44. Nope. All right. See you tomorrow.